Hey everyone, welcome to your notes on facilitated diffusion. We're going to start off again by talking about how the structure of that phospholipid bilayer is going to affect its function. So the polar heads is not the area that we are concerned with. The area that we are concerned with are those hydrophobic tails. That area, the hydrophobic tails, is going to be the one that prevents substances from crossing the plasma membrane. Now, with facilitated diffusion, what we're still talking about is a movement of particles down their concentration gradient. In other words, we're going to move from high concentration to low concentration. There's still no energy involved in this process in the form of ATP is not needed. However, what is needed is a protein channel. And that protein channel is specific to the molecule that it's going to cross. So we're going to look at the types of molecules that would cross the membrane, or that should cross the membrane down their concentration gradient with no additional energy required, but they're going to be blocked by those hydrophobic tails. So now we are looking at molecules that are either large or have charge. So large and in charge, in other words, that they're polar, are not going to be able to cross the membrane. So because they're large or they're polar, that hydrophobic, those hydrophobic tails would prevent them. So that's why we need a channel. That's why it's facilitated. So the example that I'm going to give you is a specific channel. And this specific channel is called CFTR. So CFTR is a channel that is going to be specific to the ion chlorine. So chlorine is small because it's an element. However, you'll see that it's got the charge there, so it's not going to be able to pass through the membrane. So CFTR is a specific channel, and in individuals with cystic fibrosis, this channel is not allowing the chlorine to pass through from areas of high concentration to low like it normally should. So chlorine should be able to pass through this specific channel, because channels are specific, down their concentration gradient from high to low. In other words, no ATP is required, but that channel would allow that chlorine to get through. And one of the things that I need for you guys to understand is how the protein structure affects its function. So this area right here that's touching the tails, the area that's right here in this area of the channel is supposed to be hydrophobic, but when there's a mutation, this channel gets closed off, it doesn't fold correctly, and chlorine is blocked from getting through when it would normally go down its concentration gradient. The effects of this is that you end up with a very thick dehydrated mucus when that chlorine isn't allowed to pass through that channel. There are numerous other channels that are specific that we could use. We have a sodium channel, that's not your sodium potassium pump. Chlorine channels, potassium, magnesium. You've got glucose channels, because glucose is large and polar. The key thing about facilitated diffusion is that it's going down its concentration gradient. We're going to go from high to low. ATP is not needed because of the movement of the concentration gradient, but what is required is a protein channel to allow these large polar molecules across the membrane. All right, thanks for watching.